Hi dear students, this is me Ishfaq Riaz and today we'll be discussing an important and interesting topic in physics related to the applications of Gauss's law. Dear students, you already know what is the statement of Gauss's law. Simply the statement is the electric flux to a closed surface in a vacuum, it is 1 by epsilon naught q. I have already discussed Gauss's law in detail, how to prove this Gauss's law for spherically symmetric surface, how to deduce Coulomb's law from Gauss's law. We have already discussed it. So this is the statement of Gauss's law, that is electric flux to a closed surface, it is 1 by epsilon naught times the net charge enclosed by the surface, right? Dear students, we have already discussed one application of the Gauss's law related to the electric field intensity due to a line charge. If you remember the expression for that, that is equal to lambda divided by 2 pi epsilon naught r. We have already discussed this relation in detail. Today, we'll be discussing the second application of the Gauss's law, that is electric field intensity due to an infinite, remember these points, infinite, thin and uniformly charged plane sheet. बात समझ आ रही है ना? So for that, I will consider a plane sheet of charge here, and suppose plus q is the charge that is distributed uniformly over this surface. So this is an infinite plane sheet of charge having uniform surface charge density. Suppose sigma is the surface charge density of this infinite plane sheet of charge. Now, to calculate the electric field intensity at point P, suppose this is at a distance r, and remember that this is thin sheet of charge, so that same charge appears on both the sides of this sheet. So I will consider 2 points here. Suppose this is P and Q, which are equidistant from this plane sheet of charge. Now, you already know, to apply the Gauss's law, I have to draw a Gaussian surface, right? So let me choose a cylindrical Gaussian surface through this. So let me draw a cylindrical Gaussian surface here. So this is a cylindrical Gaussian surface with circular cross sections. Suppose this is region first, suppose this is region second, and suppose this is region third. Now I will apply the Gauss's law to this region. Now you already know electric field intensity due to this thin sheet, it is by symmetry, it is radially outwards. So here this is the direction of the electric field intensity at point P, and this is the direction of the electric field intensity at point Q. You are getting it? You are following the steps. I have simply drawn a Gaussian surface, that is a cylindrical Gaussian surface. Now, to apply the Gauss's law, I have to calculate the electric flux by superposition principle. So this will be phi 1 plus phi 2 plus phi 3. What is phi 1? This will be the electric flux through the circular cross section. What is phi 2? It will be the electric flux through this circular cross section. And what is phi 3? It will be the electric flux through the curved surface of that cylinder. Now, let's try to find out phi 1. Now, by definition, phi 1 is basically equal to surface integral of electric field. Now, let's simplify it. So, this is simply E ds cos theta. बात समझ आ रही है ना? So, for region first, this is the direction of the electric field. और जो एरिया वेक्टर है ds, इसका जो यूनिट वेक्टर है that is already drawn. That's basically the outward drawn normal here. So angle is 0 here. So theta is equal to 0 degree. Cos 0 is equal to 1. बात समझ आ रही है ना? So ये जो surface integral or rather the flux phi 1 is. So E is uniform here by symmetry. So this is surface integral of ds. So this is simply E into S. What is S? It is the surface area of this circular cross section. This is flux phi 1. Now, let's try to find out flux phi 2. Similarly, I will get phi 2. It is also equal to ES. Why? Because again, E is radially outwards here. This is the direction of the unit vector, that is basically the area vector here. So angle is 0, E is uniform here. So integral of ds is again S, that is the surface area of the circular cross section. So I again get this is ES. Now what about phi 3? That is the electric flux through the curved surface area of the cylinder. Now you know, see, this is the direction of the electric field. This is the outward drawn normal. So what is the angle here? So angle between E and N came. So it is basically angle is 90 degree. Cos 90, you already know it is equal to 0. So flux through the curved surface of the cylinder is equal to 0. Now, what is the net flux through this surface? So this is the net flux. This is simply phi 1 plus phi 2 plus phi 3. So phi 1 is ES, phi 2 is ES. Let me add it. So this is ES plus 0. So I will get the flux. This is simply equal to twice ES. This is the electric flux through the Gaussian surface here. We are basically trying to find out the expression for electric field intensity due to a thin plane infinite sheet of the charge. Now let's apply Gauss's law. Now, what is the statement of Gauss's law? The electric flux through a closed surface, it is equal to 1 by epsilon naught times the net charge enclosed by the Gaussian surface. Now, what is the net charge enclosed by Gaussian surface here? So let me write here, this is net charge enclosed by Gaussian surface. Now let's try to find it out. We have already know what is sigma. It is surface charge density. So this is simply charge per unit area. So this is sigma divided by S. So what is the net charge enclosed by the Gaussian surface here? It is simply equal to sigma into S. Now, so Gauss's law will be simply flux is equal to 1 by epsilon naught times Q के बदले क्या लिखेंगे sigma into S. Now let me name it second. So let me name it first. So this basically represents the electric flux. This also represents the electric flux. So from first and second I will get. So let me write it here. From first and second we get. तो क्या निकलेगा? हाँ, ये है twice E into S. Here on RHS I have 1 by epsilon naught times sigma S. बात समझ आ रही है ना? Are you following the steps? Okay. So S and S will cancel out. तो E किसके बराबर निकलेगा? Sigma divided by twice epsilon naught. This is the final expression for electric field intensity due to a thin, uniformly charged plane sheet of charge. Now let's try to find out few points related to this very expression. What is sigma? It is the surface charge density. Rather, it is the uniform surface charge density of this plane sheet of charge. And 2, you already know it is constant. Epsilon naught is constant. So this expression, it also gives us a constant or a fixed value. So the electric field intensity, it does not depend upon the distance of the point P from the plane sheet of charge. Remember, this is infinite sheet of charge, right? So vectorially I can write. Let me write few points about this expression. So I would like to write it in vectorial notation. So vectorially ये जो E है, ये किसके बराबर निकलेगा? Sigma divided by twice epsilon naught into n cap. Where ये जो n cap है ना, it is the unit vector that is perpendicular, or I can say it is normal to the plane of sheet. बात समझ आ रही है ना? So ये जो plane of sheet हमने consider किया था like this. This is uniform surface charge density. So ये जो E की direction है, it is perpendicular to the plane sheet of charge. Number 1. Number 2, if sigma is positive, surface charge density is positive. What I mean by saying this is that if Q is positive, I mean the positive charge is uniformly distributed over the plane sheet of charge. So sigma is positive. If sigma is positive here, now you can simply see. Now ये जो E की direction है, it will be first it will be constant, you already know, or you can simply say it will be uniform. Okay? It will be normal and radially outwards, or I can say it will be outwards. If Q is positive, बात समझ आ रही है ना? If Q is positive, sigma is positive, E is uniform or constant, normal and outwards. Now, point 3 we will discuss here. If Q is negative, sigma is negative. I mean, if Q is negative, sigma is negative. What about E? It will be again uniform, because it does not depend upon the distance of the point P from the plane sheet of charge. It will be normal and it will be, in this case, it will be inwards. ठीक है ना? Now, number 4, since E is equal to sigma by twice epsilon naught, does it depend upon the distance? No. So it is independent of position of point P. So it is independent of, or I can simply say, it is independent of distance of point P or Q from plane sheet of charge. Right? So E is constant, so E is independent of R. If I plot a graph between electric field intensity, this is y-axis, this is x-axis, so E is constant because it is independent of the point, rather it is independent of the distance, right? So this is the expression for electric field intensity, or one more expression I can write it. This, since we already know this will be the fifth point, sigma. What is sigma? It is the surface charge density of this very plane sheet. So this will be Q divided by A, where A is the area of the sheet. ठीक है ना? तो इस वाले एक्सप्रेशन को हम कैसे लिख सकते हैं इलेक्ट्रिक फील्ड इंटेंसिटी? सो सिग्मा के बदले लिखूंगा Q divided by twice epsilon naught A. Remember, this sheet is thin and infinite. If it is finite, then this expression is true in the middle portion of the sheet, and that too at a point not far away from the sheet, right? So this was all about the application of the Gauss law. I applied the Gauss law. This is flux phi E. It is 1 by epsilon naught Q. This was for the light charge, and today we discussed the expression for electric field intensity due to a thin, remember these points, infinite plane sheet of the charge, and I got the final expression that E is equal to sigma divided by twice epsilon naught. What is sigma? It is the surface charge, rather the uniform surface charge density of this, that is basically equal to charge per unit area. And remember few points, E is equal to this, where n cap is the normal unit vector that is perpendicular to the plane of the sheet. Number 2, if sigma is positive, Q is uniform, normal and outwards. If sigma is negative, it is again uniform, normal and inwards. And remember one thing from this very expression, since this expression does not contain R, so it is independent of the distance of the point B from the sheet, right? So if I plot a graph between E and R, I will get a straight line parallel to the x-axis, right? And the last expression, since we usually use this very expression in the numericals, this is charge per unit area, so this is twice epsilon naught A. Hope you understood how to apply Gauss's law to find out the electric field intensity due to a plane sheet of charge. So this was all for today's class. We'll be meeting in the next lecture. Till then, Khuda Hafiz.